Hi guys, welcome to my channel. Before we get started, make sure to hit that like button and also subscribe to my channel about how architecture operates through AI and biotech. So make sure to watch the full video. The culture of the modern human being is on the verge of collapse. Rapid deforestation, resource exploitation, and environmental degradation are the results of increased infrastructure and construction activity brought on by the desire to advance more quickly. According to a BIMHOW analysis, the global construction industry produces more than half of all landfill trash and contributes to around 40% of water pollution and 23% of air pollution worldwide. These numbers should function as a red flag for the AEC sector to pause and reconsider its course of action. Overall, the creation and application of artificial intelligence (AI) are reliant on digital technology, with digital computers serving as its core. The term digital transformation describes the application of digital technologies to radically alter how businesses, organizations, research institutes, and universities run. In the context of biotechnology, digital transformation might entail the adoption of new techniques and methods to boost the effectiveness, precision, and speed of research and development, as well as to open the door to the creation of completely original and game-changing goods and services. By enabling access to big data and automating some operations, digital transformation can speed up the development and application of AI and biotechnology, enhancing the effectiveness and precision of research and development. In order to establish a solid foundation for understanding, we start this editorial by defining AI and highlighting how it differs from machine learning and deep learning. We next go over some key areas of biology where AI is currently being employed or might be in the future. Then we outline a few intersecting issues that must be resolved in order to further ongoing research. We conclude by summarizing the current hot themes in AI and biotechnology and offering a brief conclusion. Who or what is a biotechnology architect? Architects and biologists are working to design structures that are harmonious with nature in an effort to lessen the environmental impact of construction activities. This vision is realized through advancements in material form and construction technology that are inspired by nature. In order to promote the coexistence of humans and the Earth, biotechnology architecture combines natural science theories with design concepts for buildings. The use of living bioengineered materials capable of self-healing, energy production, and growth is known as biotechnology in architecture. How is biotechnology influencing architecture? The emergence of biotechnology in architecture offers a hopeful resolution to an existential quandary. To identify solutions for large-scale applications, biotechnology studies are now being conducted on a small scale. The main ways that biotechnology and architecture are combining are listed below. Biotechnology in construction materials. Research is being done on the use of mycelium, the vegetative portion of a fungus, as an alternative material for building construction. Fungal biocomposites have been the subject of groundbreaking research that has not only changed the field of material science but also paved the way for a sustainable and caring future for architecture. This fungus' widespread application is exemplified by its capacity to transform different biological wastes into long-lasting and reasonably priced synthetic building materials. Mycelium composites can successfully replace foam, wood, and plastics thanks to its adaptable qualities and uses in things like insulation, paneling, flooring, and other furniture. They are a superior option than all the other materials since they exhibit better thermal and acoustic insulation qualities than conventional materials like synthetic foam and engineered wood. Self-healing in order to utilize them in space architecture. Concrete mycelium derivatives are likewise being researched and tested. The ability to grow building materials on another planet, should the research be successful, would assist lower the overall cost of creating a new home and transportation. The idea of self-healing concrete is the subject of yet another study Henk Jonkers is doing at the Delft University of Technology. When ambient moisture enters into a concrete mixture, hydrophilic bacterial spores develop and eventually mend the microscopic cracks. This is the theory behind it. When examined more closely, the bacterial particles revealed a triggering response to a moist environment that encourages the development of calcite crystals. Air circulation systems using biotechnology. At MIT, Hiroshi Ishii's team has conducted research and created biological materials that adapt to water by changing structure. This substance, which works similarly to self-healing concrete, is constructed of layers of bacterial spores and latex that expand or contract according to how much water is absorbed by the system. Similar techniques are being developed to make the entire exterior membrane of the building out of such materials, allowing the building to breathe and maintain a steady flow of air throughout. This technique will aid in the exchange of gases, enabling the building's occupants to breathe and have access to highly oxygenated air, as well as aiding in the structure's ability to have a life of its own. Biotechnology as a source of energy. The Hub for Biotechnology in the Built Environment, HBBE, is researching the metabolism of buildings, which is another extremely typical application of biotechnology in architecture. According to theory, the functional component of this building processes the biological waste produced by the occupants and transforms them into pure forms of energy and other valuable goods. It uses small-scale bioreactors to turn food and human waste into a little amount of electricity, assist in the production of nutrients and enzymes that can break down plastics, and create useful products. The microbiome is made up of environmental bacteria and viruses. Another goal of HBBE is to look for ways to improve harmony between the humans living in the complex and these microbes and viruses. Building design using biotechnology. A multidisciplinary field called biomimicry takes useful design concepts and operational tenets from nature and puts them into an architectural form that users may interact with. It deals with the design and experimentation process using materials that are naturally occurring to discover the best answer for a sustainable and secure future. Some of the oldest recorded instances of biomimicry date back to 1436, when Filippo Brunelleschi used an eggshell as a model for his cathedral in Florence's thin and light dome, setting an example that encouraged many others to follow in his footsteps. In the modern day, biomimicry is employed to address issues including resource scarcity, biodiversity loss, and climate change. One can use the biosphere to inspire themselves as well with the proper tools and awareness of resources. A good example. Biennale Architectura 2021, the Alive Pavilion, the living photographed by David Benjamin High, the Young Architects Program, VIP, competition's best design intervention was called FI. David Benjamin, the chief architect of The Living, concentrated on using a more environmentally friendly method when creating this design, to investigate new biodegradable materials and take on the issue of developing a pleasant microclimate for the future. The company introduced bricks made of mycelium composites that were produced in a mold and joined by a digested adhesive. The verdict. By Mitchell Joachim, the poem Cricket Shelter. By preventing the exploitation of our future environments and assisting in the development of structures that are more fit and sustainable for today's needs, the application of biotechnology in architecture enables us to better the world for coming generations. Although the majority of current research on the subject of biotechnology in architecture focuses on self-sustenance, the actual result wouldn't be attained unless all of the systems work together to build a holistic ecosystem. So that's it for today. We hope you enjoyed the video. Use the comment section below to tell us your thoughts about the video. Also, make sure to subscribe to our channel and click the bell button to be notified of all the latest videos.